Now we're going to see what we mean by the horizontal line test. Okay, assume that we are having some function f of x and its graph is something like this. Okay, so if a line, okay, any line that's horizontal and intersects the graph of the function only once, we say that the function satisfies the horizontal line test, or we can say that f is injective. Okay, that means we can't cross this function more than one time. Okay, let's see what we can have here. So this one means that given any function, if f of x is equal to f of y, let's say this is our x, this is our y, okay, we need to have x equals to y. This one, they have to be the same. Okay, if we have two values, let's say if we have f of a equals f of b, but a is different from b, then we say that f is not injective. Okay, we're gonna see some examples. Okay, let's consider first the line y equals x minus 1. Okay, we can graph this one very easily. Okay, so this is the graph, this is my function, and I see that if I have any horizontal line, it does cross the function only once. Okay, therefore this function is injective. Okay, if I have this function given by y is 1 minus x squared, I can graph it. So here I see that the x-axis, okay, is a horizontal line. It crosses this function in these 2 points, okay, 1 and minus 1. They have the same value, and they are not the same, they are different. Therefore, f is not injective. I can see more than that. I can see that every time I cross the graph of this function, I have 2 points, 2 different points that they have the same value, but they are different. Okay, this means that this function here is not injective. Okay, we can solve this one here and see what these points are. In fact, we can do it geometrically. If let's say this is my a here, so this is a, in minus a has the same value. Why? Because f is even, because I have f of a is equal to f of minus a. Okay, and because f is even, it's not injective. Okay, anyways, the key idea is that if we have a horizontal line that intersects the graph in more than one point, then f is not injective. Okay, and it means if it's not injective, it means that f of a is equal to f of b, but a is different from b, like in here. So we have f of 1, let's say my function f of x is 1 minus x squared. I have f of 1 is 0, f of minus 1 is 0. They have the same value, but 1 is different from minus 1. Okay, so the key idea is that if you have the graph, you can see if your graph or your function is injective or not by just making the horizontal line crosses the function and see in how many points it does that. And from there you get the idea if it's injective or not. But the most important thing is to be able to solve this one here. This is algebraically, because sometimes we have some functions that we can't graph, but we can prove algebraically if they are injective or not.